We continue with session 4 on our SHS Core ICT lessons. Today's topic will be on introduction to computers. I don't know if you heard of this story. This story is told of a man who had wanted to seriously beat up the computer for placing his son in a school remotely away from his location. This happened during the time when the CSSP, that is the Computer School Placement System, began. And probably he had planned for his son to go to a certain school, but it seems his son was not placed there, so he had wanted to find whoever the computer was and then beat him mercilessly. I'm wondering why the man thought the computer was a human being, and I'm also wondering why it caused him to behave in that manner, going on radio to cause himself such a disgrace. It could be a number of factors that contributed to this. One of them could be that he was an illiterate. That is someone who had very little knowledge in computing itself. Probably could be somebody who was not educated at all. So he didn't know what the computer was, and it could be that he did not know what it stood for. That is what the computer's functions were, what computers do. It could be that he didn't know, and that he also had no knowledge about the computerized school selection and placement system. He had no idea about it. If probably he had enough explanation as to how the system works, probably this kind of disgrace wouldn't have come his way. And the most worrying thing is, it seems like nobody also bothered to explain things to him. First of all, what the computer was, and then what the CSSPS was. So that could be the major issue. Now, we had a good laugh though. I don't have the clip right now. If I had, I would have probably played it for you. But even though it's funny, in a way, it put him under public ridicule. What we learned from this, in order to forestall such embarrassment, we have to learn about what the computer is. We should know what the computer is. We should be able to understand what the computer stands for. So in our lesson for today, we will learn the meaning of the computer, and we will learn the components of a computer. We would also discuss the advantages of using ICT tools, which includes computers. Then also discuss some of the disadvantages. Then we will we will continue with the types of computers, and then we will look at some of the differences between the two main types. You will know what the types are. Alright, but we will take a break and then continue later on. What is a computer? If you remember, in our previous lesson, I did explain that the computer is the most important information processing systems. I gave you an example of an information processing system, and I did explain that an information processing system simply refers to any device that has the ability to ability to capture data and then undergo the various operations under the information processing cycle. So for instance, I did explain that it is not every information processing system that performs all the operations of the IPC, but the particular one that has all the ability is the computer. And these operations performed under the IPC includes the ability to accept data as input. That is, a computer has the ability to take data from a user or from another system, and whatever is sent in there is referred to as input. So we have input operation and we have input. Input operation is the activity, and then input itself, we use it to represent the data. Then the second operation that a computer performs is to process data into information. That it has the ability through its processes to change or transform the data that was entered in a form of input. It transforms it into information. Then it has the ability to store the information it has produced. That is, once the information has been produced, the computer will keep that information somewhere so that when we need to access or use such information again, we don't need to reprocess it. It will be a waste of time. Rather, we go and pick what has been processed and make use of it. Computer also has the ability, after storing, it has the ability to bring out the information. Now, when information is coming out, we also refer to such an information as output. So note this: data being sent into the computer is referred to as input, and the information that is coming out of the computer is also referred to as output. Then once information has been given out, then the computer has the ability to communicate that information with other relevant ICT tools. So for instance, I can transfer information from my computer to another computer through what I explained earlier as a network. We shall deal more with networks in, I think, Form 2 or Form 3 lessons. So every computer, yeah, I said most, but it should have been every computer is electronic. Every computer is electronic because most computers have most of its operations taking place in electronic circuitry, right? They use electricity. It signals is in the form of electronic signals. So that is why every computer is electronic. That is, in the first place, it uses electricity in all its operations. So let us define what a computer is. In simple terms, a computer can be defined as a set of electronic devices that receive data, process the data into information, stores, outputs, and communicates information. It is a set of electronic devices that receives data, processes the data into information, stores, outputs, and communicates information. That is one definition of what a computer is. Another definition given to computer is that it is a set of electronic devices that accept data, process it, and produce meaningful information. A set of electronic devices that accept data, process it, and produce meaningful information. You can also define a computer as electronic devices that can follow instructions to accept input, process data input, and produce information. So the new element here is instructions, right? You see instructions there. Another definition is a device that receives, processes, and presents information. A device that receives, processes, and presents information. When you look here, present here takes two forms. The one that comes as output and the one that you share that information. So you present that information to other people. That is why you have the word present there. So present takes into recognition output and communication. Alright, let me give you another definition as device that computes high speed mathematical and logical operations, or that assembles, stores, correlates, or otherwise process information. A device, or you can say a set of devices that computes, performs high-speed mathematical and logical operations, or that assembles, stores, correlates, or otherwise process information. We can also define a computer as a programmable machine that can accept, process, store, and retrieve information. It should have been information, not data. But if you remember, we said there is derived data. So derived data can also be retrieved data. So here we can accept this definition: programmable machine that can accept, process, store, and retrieve data. Alright, that is, I think I've given you a number of definitions for computer. You can go back and then try to understand, or maybe you can write some of them down. Let us look at the components of a computer. A computer is made up of two components. These components are hardware. When we were discussing information system or computer system, I did say, or I did explain hardware. I gave one definition of hardware. I'm also giving another definition of hardware here. Whichever one you prefer is correct. Hardware can be defined or explained as the physical, electronic, and mechanical equipment component of the computer. Note the key words. Physical. It is electronic. It is mechanical as well. So some parts of hardware may be mechanical in nature, others may not be mechanical, but every computer hardware is considered as being electronic. Okay, and you can also use the physical as well. So the physical, electronic, and mechanical equipment component of a computer refers to the hardware. Software, on the other hand, refers to the set of instructions that determines the operations of hardware and how those operations are performed. Software refers to the set of instructions that determines the operations of hardware and how those operations are performed. You can refer to instructions also as commands. So you can say the set of commands that determines what the hardware should do and then how it should do those things. Okay, so that is what the definition here is trying to tell us. Let us come to, please, before I come to advantages of using ICT tools, you should note that there's a difference between a computer system, components of a computer system or components of an information system and components of a computer. A computer system comprises 6 components, as you were explained to. The components, if you do remember, were liveware or people, and then you had data or information, you had procedures, then you had hardware, software, then you had communication. Those were the components of a computer system. But when you come to a computer, there are only 2 components, and those components are hardware and software. Therefore, do not confuse computer system with a computer. Let us discuss some of the advantages of using ICT tools, which includes computers. The first advantage of using ICT tools is that they have made work easier for various sectors of the economy, right? Whichever sector there are, whether you have education, whether you have health, whether you have business, they have made working in those sectors very easy, because if they were doing manual work, look at time wastage, look at resources they would need to use. Okay, and even consider the efficiency that would be affected. They will not be able to work as fast as they are able to do now with the advent of ICT tools, including computers. That is why we say that working with ICT tools I have made work easier for the various sectors of our society and our economy. Another, I think I also talked about this, they have helped reduce time spent in doing work. Let us consider, for instance, if, let's say, I had to send information from Kumasi to Accra, consider the time I would spend in transporting that letter to Accra, or that information to Accra. But within a matter of minutes or seconds, I can send that information. And if I'm able to send my information within that time, then I have reduced time spent in performing that work that I normally do. Another advantage of computers is that they have helped in producing accurate and more reliable information. That is, whatever information an ICT tool produces is always accurate. That is, there is no falsehood in the outcome or in the output that a computer, and for that matter other ICT tools, produce. If there could be an inaccuracy, then it would come from the person who fed the data into the computer. So if you give it wrong data, it will produce a wrong result for you. So I don't know if you've heard of GIGO, G-I-G-O, garbage in, garbage out. So if you feed it with garbage, you should expect that it will give you garbage as a result. If you feed it with the right data, then expect that the right information will be produced. So ICT tools by themselves do not produce false information. If the information given is accurate, then you can rely on that information to perform any activity or to take any decision you need to take, because you are confident that that information is that reliable, and you can defend whatever comes out of it. Another advantage is they have made it easier to share information with other people, irrespective of their distance away from each other. Now I can easily pick a phone and call my friend. I can easily interact with him with very little work involved in it. I don't need to necessarily, let's say if my friend is at Beka and I'm staying at, let's say, La Paz. If I want to share some sort of information with him, I don't need to board a car and go to Beka, right? La Paz. I don't need to move there and then chat with my friend to deliver or share information with him. I can easily pick up the phone and talk to him. I can also choose to probably use social media platforms like WhatsApp, Instagram, and Facebook, and so on and so forth. So it has made it easier for us to share information with other people, even if they are outside Ghana. Yeah, it's very easy, especially with these social medias. You can easily chat. Once you chat, you are sharing information along the way. Another advantage is that there is more productivity for individuals and industry. Let's take, for instance, Guinness Ghana Company. Previously, they had to make their own raw materials. Then they had to make sure that certain processes, human beings will have to make sure that processes take place so that the various drinks are produced. Then when they are produced, it will have to be human beings who will fill the bottles with the drinks. Then after filling, someone will have to seal the bottles with their corks, right? But now we have computers, ICT devices that take care of most of these activities. Probably what human beings will do is probably carry the raw materials to these machines. Right afterwards, the machines will process and then fix the corks on top of the bottles, and then the human beings will carry the boxes containing the bottles probably to somewhere, either using probably an automobile or something. Okay, so consider when human beings were doing all the work. Look, human beings, you go tired, right? And even you cannot work so fast. But with the introduction of computers and other ICT devices, now the companies can produce more products, right? They can produce more of the products and sell. So if you are able to produce more, then productivity increases, efficiency increases, time spent will go down. So if they are able to utilize time very well, so that they produce a large number of quantity beyond what human beings would have done, right? So there's more productivity for you. Let's also consider our accountants. Formerly, they had to use ledger books to compute or keep records of their accounts records. But now all they do is probably use some accounting software, and that accounting software in a matter of seconds or minutes computes all their calculations for them. Probably if for instance, if computers were not available, they would have to sit down, do all the calculations. If a mistake is made somewhere in an earlier cell, they will have to trace it all along the way and correct it. And once they correct it, they have to effect that correction through and through to the final results. Okay, but for computers, you don't need to do that lengthy work. All you need to do is to give it appropriate formula, and you are done. You just feed data. Once you feed data into it, it computes your results for you. If you change one thing somewhere, the computer, and for that matter, all ICT tools involved, will automatically correct or make changes to the other computations that are affected by it. So you notice that productivity increases. It reduces the workload on you, so you're able to do more work. That is why we say productivity will go high for both individuals and industries. Computers have also made it easier to search for and access huge amounts of information, which help us to learn and make more reliable decisions. I did give example as students. You go to school, you need to read so much on each topic you are taught in school. It does happen that your parents will not be able to purchase so many books for you to learn on one subject. For instance, they may buy about 2 or 3 books for you, and that is all. But courtesy ICT tools like internet and computers, you are able to find, let's say if you are given a topic, you are able to find websites that contains information about that topic. You can find several websites that contains information about that topic, and then once you assess them, you read and you build up your understanding into that topic. You accumulate a lot of information, and then you use that information to build up your knowledge. And once you gain that knowledge, you are able to take right and reliable decisions. So if you know that you are certain by exams, you know you have learned from several angles. So whatever output you'll be writing in your exams, you are quite certain that whatever you are producing is correct, and it will earn you the marks after comparing, of course, to what your teacher gave you in the form of notes. Another advantage is that they have made it possible to create, keep track of, and maintain personal, financial, and accounts records electronically. Alright. I have already spoken about records before. Let's say you are a student and I say I'm taking your records. Basic information I will take from you may be your name, your date of birth, your age, where you are coming from, where you stay, and if you are a boarder or a day student. Yeah, those are some of the basic particulars I'll take from you. When we put all those basic particulars together, they form your records. Okay. Apart from taking records from individual human beings, we also have financial records. Our accounting friends, or those involved in financial sector like our banking people, they keep a lot of financial records. When you go to your business office, they too keep accounting records. Now, instead of keeping them on paper, rather they keep them on electronic gadgets. For instance, they can enter the records onto the computers, store them, okay, then they can copy them and keep them somewhere else. Probably they can even load it on a cloud storage. I'll explain what cloud storage is when we get to computer storage technologies. Okay, so they can keep them on cloud storage. In situations where, let's say, if they had kept such records on paper, if there's a fire outbreak, they lose all their records because the papers will burn. But even if the computers burn and they had kept copies of those records somewhere else, okay, let's say they had kept them on cloud storage, they can easily copy what they kept there, and then they have not lost their records. So you see that they're able to keep track of and they are able to maintain their records very well. I believe I've made it. I've made you understand this point as well. Computers have also made it possible. Sorry, ICT tools. When I use computers, you should understand that I'm including all the other ICT tools. So forgive me if I do so. They have made it possible for us to be entertained. And I did give you a lot of examples, and when we're discussing uses of ICT tools in entertainment, leisure, and media. So you have a lot of games, you have programs, you have music, and you have a lot of you have access to a lot of music and movies that have better quality, better sound, bytes, and better graphics. So as you use them or as you access such entertainment platforms, you gain entertainment, you're able to relax, and you reduce the stress that you might have accumulated. So let's say you go for a whole day class from morning to maybe 4 o'clock. Probably you relax a little bit, then you listen to some music or you watch a movie or something. Then your brain is relaxed and refreshed for you to go on again for your later studies, let's say at prep or something else afterwards. An additional advantage of ICT tools is that they have made it possible for us to undertake various forms of transactions. I gave you examples of transactions. For instance, you go to ATM machines and you withdraw money. When you withdraw money, you have undertaken a transaction, right? Instead of going to join a long queue in a bank to take your money from a teller, rather you can just go to your ATM machine with your ATM card, and then you withdraw your money. Besides that, you can also conduct transactions through internet. Let's say there's a particular software on the internet. It is owned by, let's say, a company in Germany, and I want to buy that software. I can easily purchase that software by first of all letting them know I would want to buy the software. Then they'll give me a platform to fill my details, and after I filled my details, I'll give them my Visa card number, then or details. Then they would withdraw the appropriate amount, right, through a bank somewhere. So the bank will keep the money in place till I get my software. Once I get my software, then the money is given to the software company. Then I'm able to also use my software here in Ghana. So I don't need to travel all the way to Germany to purchase that software, right? And probably I don't need to make somebody to buy that software, post it through how do you call it, the postal services before I get my software. That is how that is an example of transactions that can be conducted through ICT tools. So it has made it easier to undertake these sort of transactions. Of course, that is not all the transactions that we can think of. There are several transactions that take place. But this one is just an example for you. Another example is that ICT tools have made it possible for us to handle dangerous and complex situations. For instance, if we need to mix certain chemicals, and these chemicals are very, very dangerous, so that if a human being goes into contact with such a chemical, probably it can be hurt. It can be hurt. So in order to forestall such situations, we would rather use ICT tools. We will give commands through the ICT tools, and the right dosage and everything will be mixed, and we reduce the propensity of probably making mistakes. Because if, let's say, we need a half bottle of one chemical to mix with let's say another half bottle, and the human being makes a mistake, probably he forgets, and he mixes, let's say, half with a full bottle of some chemicals, probably it may spark fire and probably kill the person involved or something. Okay, so in order to, if not, apart from probably killing him, it may bring about a lot of distraction. Okay, it may bring a lot of distraction. These people, how do you call it? Those who develop nuclear weapons and nuclear reactors. Theirs is very, very dangerous. The least mistake they make can cause a whole damage. I don't know if, I think it happened in Japan or China. Okay, is it Fukushima or something? I've forgotten where it is, but it caused a lot of havoc. A lot of people died, and a lot of people got cancer out of a mistake that was made, and there was a reaction within the reactors, and the chemicals exploded, causing such problems. So in order to forestall all these, people will have to make sure that the ICT tools are used appropriately to control and manage these situations or these plans, okay, so that we don't cause ourselves these problems. Besides those that deal with chemicals, if you remember in our earlier discuss on uses of ICT in health, I did explain that doctors and other medical officers perform complex surgeries, and these complex surgeries, they make use of a lot of ICT tools. If these tools were not being used, the likelihood that a complication may arise, or probably they may not be able to perform the surgery well, or probably they may not be able to even detect or properly get rid of, let's say, that disease or something may be high. But once they have access to these tools, they are able to quickly perform these operations, properly identify what or where a disease is, and then they quickly treat it. So that is one advantage. Let us come to disadvantages of using ICT tools. The first disadvantage of using ICT tools is that confidential information may be leaked or accessed by unauthorized people. Let us take, for instance, Edward Snowden. He leaked a very important and security information of the United States government. That information was supposed to be kept secret, so it was classified information, right? These information, when they are leaked, the outcome may be very devastating. For instance, now there's a little bit of, or I shouldn't say a little bit, but a lot of distrust between US and various other countries because of what happened. They were spying on various individuals and leaders. They were spying on them, but probably the intention may not be to do something bad, but it may be that they might have wanted to protect them in a way or something. But once it gets out, the damages alone cannot be controlled. In the same way, if there's a confidential information about a company and that information is not supposed to be accessed, it can be leaked. For instance, I may be using my machine as, let's say, an accountant. I may be using my machine, and that we have information about the revenues of a company. Okay, now if I leave my machine on for another person who is not authorized to access my machine to get access to the accounts records, probably our main banking records, the person can easily manipulate and then steal some of the money belonging to the company, right? So a lot of confidential information that is not supposed to be known by people who are not expected to have access to them, it may be leaked because of ICT tools. But if, let's say, they were not on ICT platforms, probably they might have been kept safe somewhere without people getting access to them. Now you can sit somewhere and hack into people's records, okay, and steal information to leak. Okay, you just steal information and, hey, this is what these people are doing. You see it. Probably issues of national security and so on. I hope you understand me. So, confidential information that is expected to be kept secret may be leaked. And this is because of ICT tools. Most ICT tools become redundant when there is no electricity supply. When we say something is redundant, in the context for which I speak, I mean it becomes useless. You can't use it to do anything. Because remember, we said every computer or every ICT tool requires electricity, whether it is battery or it is direct electricity. If there's no electricity, every machine becomes dumb. They become useless. You can't use them for anything. So you can imagine, once it becomes redundant, then you should expect that work comes to a halt. You can't do anything again. You have to wait till light comes on. Let's take, for instance, our banks. If their electricity goes off, whether it is generated or whether it's coming generated from ECG or something, if it goes off, it means they can't do anything in that bank. Okay, no one can withdraw money, no one can deposit money, right? So you have to stop virtually every work till electricity comes back. That is a disadvantage. That is a big disadvantage of ICT tools. Work comes to a halt when there is electricity failure, or when an ICT tool being used malfunctions. Let's say there's a fault. There's a fault on one of the devices. Once a fault generates, that fault that has generated within that particular device makes it inaccessible, or it malfunctions. You can't use it, so you have to stop virtually and call someone to repair it before you can continue. So in a way, you have to stop, wait for their repair before you can continue your work. So that is a disadvantage, because we said it's supposed to lead us to increase in productivity and efficiency, right? Now, if I have to stop work, then my productivity goes down, my efficiency goes down as well. People also perpetuate computer fraud, or what we know in Ghana as Sakawa, or 419. We have so many unscrupulous people who deep on suspecting people of their resources. Let's say someone is in America and someone will be in Ghana, a young man who has decided not to go to school to learn, to become a proper citizen of the nation, or probably learn a trade to become also a good citizen or a proper citizen, will sit somewhere by the computer, deceive people, oh, I'm this, I'm that, and that, and that, especially through platforms like Facebook and Instagram and those stuff. They will deceive them, oh, I have gold here, bring me this money, right? Or they can say, I'm sick, or they will lie to people, just lie to people to find a way to dupe them, to steal their money. Besides that too, there's a lot of hacking going on. Okay, so I can easily hack into a bank and then steal their money. Okay, transfer huge amounts of money from, let's say, someone's account into my account, probably in a different bank. And then I'll quickly go and maybe use ATM card to withdraw all that money. So you may not even know. We have a lot of ways of preventing, detecting how money was stolen or something. You see it. So computer fraud happens a lot. But now computer security and ICT security is also improving. Therefore, we're able to easily prevent such things from happening. But that does not mean it doesn't occur at all. They do occur. Another disadvantage is that it leads to dislocation of workers. ICT tools normally can do the work that could have been done by several people, and this may lead to unemployment. So when we talk about dislocation of workers, we are also referring to unemployment. So one computer or one ICT tool can do, let's say, the work of about 10 people. So what happens? It means we have to sack those 10 people, because remember, they are being paid salaries, okay, their health insurance, and a whole lot of things. And probably they may make a lot of errors, but as I said, computers do not make, ICT tools do not make such errors. But human beings may make errors. So if the company considers the advantage of he increasing productivity and he cutting down costs, probably he will go in, the company will go in for the ICT tools and lay off the workers. And when workers are laid off, especially in our part of the world, children are affected, wives are affected, and other family members are affected. These people will not be able to get the salaries needed to take care of themselves and their family. Therefore, it leads to a lot of it may lead to social vices coming up into our society, and people will also, if care is not taken, it may lead to people becoming poor. Because if I'm not employed and if I don't have any sort of work to do again, if everybody is employing ICT tools, then it means a lot of people will not have work to do. Okay, and the more people are not getting work to do, then the more they are becoming poor. ICT tools working involve excuse me. Work involving ICT tools may remove employees from social contact with other people. As human beings, we need to interact with each other. I need to speak to you. We share a lot of ideas. We have fun. And then we become more productive. Okay, even as we speak to one another, it serves as some sort of motivation to do more. But these days, when you enter your office, once you enter there, beside break time, you are supposed to remain there, work. If you need information from somebody, you can easily pick, you have to pick probably the intercom, call that person in that office, whatever information you need to deliver or get, you deliver to him or you receive it from him, right? So you don't get the chance to mingle more, to socialize. And if people don't socialize, then they are becoming they are not becoming sociable. Okay, they don't get to mix with others. So our social lives will be affected. Our social lives will be affected. So that is a disadvantage of using ICT tools. Another disadvantage of using ICT tools would be the abuse and misuse of ICT tools. Some people, instead of using it for the right things at the right moment, they will rather use it for the wrong things. For instance, people will go to their offices instead of working through the ICT tools. They will sit down and chat with friends on Facebook. They will use their phones to chat on WhatsApp, on Instagram, and so on. Now, this causes a reduction in productivity. Instead of you to probably pick your learning notes or probably use the internet to learn a lot on the topics you are learning, you stay there for so long playing games. Okay, so instead of learning, you are wasting time for games. So though you are entertaining yourself, though you are relaxing, you are doing that at the expense of your learning, and that is a negative effect. You abuse it and you are misusing it. Lower productivity in situations where workers have not been trained to effectively and efficiently handle ICT tools in the workplace. We are not so conversant with all the ICT tools. Not everybody is that conversant. So let's say I'm using my paper and pen to do my work, and you go and bring in a computer. Excuse me. You go and bring in a computer for me to use. I don't know how to use the computer. How will I work? You see it? So my work will become hampered. And if my work becomes hampered, I'm not able to produce much results. Therefore, leading to lower productivity. Hence, if I'm supposed to use a device The company must make sure that I'm properly trained in how to use it. If I'm not able to use it, then it means I'll not produce much of an outcome. Let me see how many more. Okay, we have two. Let's discuss the two. Improper use of ICT, improper use of and arrangement of ICT tools can cause health risk to users. There's a proper way of arranging ICT tools, and there's a proper way of handling them. If you don't do that arrangement very well, and let's say, for instance, your desk is supposed to be of certain height, your chair is supposed to be of certain height, your sitting posture must be in a certain way. We will learn those later. Your sitting arrangement must be of certain way. Now, if you don't position yourself very well and you dislocate yourself in any way, as you continuously do that, part of your body will be affected. Okay, and that serves as a health risk. Sorry. Your eyes, for instance, are not supposed to sit too close, especially to the monitors that look like TV. We'll look at their proper names later on. Now, if you sit too close to them, your eyes will be affected. Okay, because the rays will be entering directly into your eyes. The same thing if you are watching TV, right? You are supposed to sit a bit far away. You are supposed to hold your phone in a certain way when you are making a phone call. Some of you, you lean towards the phone, okay, towards one side of the neck. If you continuously do that, you feel pains in your neck, okay, and therefore using ICT tools can lead to health risk if you don't use them well. So learn how to properly use them and learn how to manage your body in relation to using various ICT tools. ICT tools, we say, are also breaking the social fiber of the society. The social fiber here refers to the proper behavior that is expected of every citizen living within a community. So in my community, it is expected that you are expected to maybe dress in a particular way. You are supposed to show certain mannerisms. You are supposed to show a lot of respect to the elderly. You are not supposed to engage in any form of vices. That is what the society expects. But because we interact or get access to a lot of things on the ICT tools, including internet, we learn a lot of things there. Please remember that you can find very good things on ICT tools, and you can also find bad things on ICT tools. Take, for instance, on our television stations, on our TVs, you watch them. Some of them show good programs at certain times. At certain times too, the things they show there is very appalling. Even the musicals that are coming up, the kind of dressing people are putting up, exposing various parts of the body. Okay, now you people have learned how to, you call this autofesta or whatever. So you dress in a certain way. These dressings are not something that is accepted in our culture. Okay, so because we have gotten access to these ICT tools, we are losing our moral fiber. the good behaviors that we were supposed to be exhibiting. Even now, people talk to people anyhow. They raise their hands. You know, when you are talking to an elderly person, formerly you had to place your hands at your back, show a lot of respect. But now people talk anyhow. They respect people. They disrespect elderly people. Okay, these are all learned through ICT tools. They are not good behaviors that is expected from a Ghanaian, if I should say. But we've copied them from other cultures, because for those people, even a little child can talk anyhow to his parents, and you dare not show any form of punishment, else you'll be in trouble. People also go there to watch a lot of pornography. Porn has become more order of the day. You go to the net, you can easily access porn on the net. You go to these people who sell CDs, you go and buy CD, you come and slot into your machine and you watch. Okay, now it entices you to go and have sex. Okay, you go and have sex, you disturb your studies, because by the time you're supposed to be concentrating, using your energy to learn, you are wasting that energy on girls and boys. Okay, and besides that too, you'll be thinking, instead of thinking about your studies, whilst you are even with the book, your mind is on a girl you are sleeping with, or with a boy you are sleeping with. Okay, all these are some of the negative things ICT tools have brought into the society. Not that they were non-existent, but they have increased or they have heightened their occurrence. Some of them, yes, they were not existent at all, but some too, people going to have sex, blah 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 blah. They were there, but now it is despicable. Okay, now things have become normal as people will perceive it. But in our society, in our culture, the systems that were there would have controlled these things. So our various traditional customs would have stopped them. But now, because we have access to these, we don't even recognize these wonderful cultures anymore. Therefore, ICT tools can be of very, very negative effect within our communities and within our societies. You have learned advantages and disadvantages. You would have to decide whether you are going for the good side of ICT tools or you are going for the bad side of ICT tools. It's left up to you. But I always advise, choose the right thing, which is doing the right things at the right times, at all times, so that one, you will not find yourself at the wrong side of the law, or you will not later regret of your actions. So instead of wasting your time doing certain things, at your age and at your stage, concentrate on your studies. Become a better person in the society. Okay? Because right now everything boils down to you learning. Alright. I hope you have understood and you would agree with our discussion. Let us come to the types of computers. We have different types of computers. In all, there are 3, and these types are analog computer, digital computer, and hybrid computer. Let us discuss analog computers. Analog computers, they are types of computers that solves a problem by counting or measuring the various infinite fractions in a physical condition or situation. Note that analog computers are normally used for measurements or for counting purposes. And what do they measure, and from what do they measure? They normally measure from something that is natural or something that is physical. Okay, so let's say, for instance, an analog computer will be used to measure the level of rainfall. Let's say a rain gauge or gauge is used to measure the level of rainfall. Because rainfall is physical or natural, then we will need an analog computer. Now, the kind of data that an analog computer would measure, you don't get them in finite form. Okay, like 1, 2, 3. No. You see that it's in fractions. You measure in small bits because you can't get them in that whole numbers. Let's take human temperature, for instance. When a nurse brings a thermometer and then affixes it on your hand, or probably in your mouth, or let's say a sphygmanometer, to check on your temperature, you notice that as he increases the pressure in the thing that he attaches to your arm, you notice that gradually it is able to pick on your temperature, and the mercury in the device will be rising in bits, in small fractions. So let's say it will start from 0, then you get 0.1 or maybe 1.5, then you go to, let's say, 1.75, then you rise, and it rises small till it reaches your final temperature. That is why we say it is an infinite fractions. The figures that you will get to measure, they are not finite. They are not whole in nature. They come in small bits. If you are measuring rainfall, the rain will be falling in small bits. It will be falling smallly into the rain gauge, right? Therefore, if you are reading, you see that it will be rising in fractions, small bits. If you have the scale on the gauge, you see that it will be reading in small bits. All right. So that is why we say its data is infinite fractions. And remember, every analog computer works on something that is physical or natural, a physical condition or situation or object. The computer processes data in a waveform. Analog computer always processes data in some sort of a waveform. So as I said, it rises, and sometimes you see that it will be falling a bit, and they may rise again small, fall a bit, probably rise, fall, and fall. So if, let's say, you are drawing a curve, you see that it will be like a wave. Do you understand me? It will be in a form of a wave. Examples of physical conditions that analog computers handle are speed, temperature, pressure, electrical voltage, mechanics, and hydraulics. So these are some of the physical conditions that we normally use analog computers to measure. Please, it doesn't mean we have analog computers that can do several things. No. Analog computers, if there's an analog computer for measuring the speed a car is traveling, it can only measure the speed that car is driving. It cannot measure any form of temperature or pressure in any way. Okay, if let's say we need to measure your temperature, there's a particular device for that one alone. That device cannot do any other thing. Okay, no thermometer cannot measure speed of the car. And I don't know if you've ever seen these Gawo sellers, those who sell petrol and diesel without using the machines that fuel stations use, the proper ones they use. When you go, you notice that he will first of all pump the petrol into some glass up. Then you notice that there are measurements on the glass. Then as he pumps the fuel into the glass, you notice it will be rising in bits, and then when it gets to the point which he thinks is the right level for which the customer is buying, then he stops. So probably he will have to use his eye to gauge to see that yes, this is the right quantity. Right, that is the right quantity. Then he stops and then pumps it into the customer's vehicle. That is a classical example of an analog computer. Alright, so as I have told you, the figures are in bits, and then it continues in a way. So you are likely to get the results or the inputs in a form of something that is continuous. When you say something is variables, okay, something that is continuous variables, you get a result that may be either rising or falling, and it follows each other. Okay, it follows each other. So let us look at a proper definition of an analog computer. You can define an analog computer as a type of computer that measures continuously changing fractions in a physical condition or object. Okay, it is a type of computer that measures continuously changing fractions in a physical condition or physical object. Let me see if I can find a different definition for you as well. Yeah, another definition. Let me pause here and then type for you. Alright, so this is another definition for analog computer. It is a type of computer that attracts and measures continuously changing fractions of data in a physical or natural object, system, or condition. So the additional information here is that every analog computer has the ability to attract its own data. So if, let's say, the thermometer wants to measure your temperature, all we need is to fix it probably in your armpit. Then once you fix it there, it's able to attract or take its own data. It's able to measure its own data. Do you get me? So that is another definition of an analog computer, a type of computer that attracts and measures continuously changing fractions of data in a physical or natural object, system, or condition. Let's say we want to check the humidity in the atmosphere. The device we use will be able to determine, it will be able to attract its own data as to what the humidity is. Nobody has to feed it with the data. Okay, it has the ability to attract its own data. Take its data from a physical system or a natural system or an object or a condition. Examples of analog computers are thermometer, speedometer, hydrometer, barometer. This one, let me take my time. Sphygmomanometer. Let me pronounce it again. Sphygmomanometer. Right? Then you have weight scales. You learn more about these, I think, in your integrated science. But these are pictures of some of these devices we are talking about. These are the analog computers. So, for instance, you have the weight scale. You go and stand on it. Then probably the reader will be at the initial stage of 0. Then as you stand on it, it will be moving up and then it will be rising clockwise or anti-clockwise till it gets to your actual weight. Then when it gets there, then it stops. Now, if you observe, it will be moving in small bits. So it will be measuring your weight in small bits till it gets to your actual weight. So the data will be in some sort of continuous data, and it will be in bits of fractions. So these are the pictures of the examples we mentioned. Let us come to digital computers. Digital computers, they are the type of computers that accept and operate on discrete data in the form of electronic pulse or signals. This type of computer accepts and operates on discrete data in the form of electronic pulse or signals. If you remember, for analog computers, we said data is in continuous fractions, that is in bits. But for this one, it is in discrete, which means it is in whole numbers. So if it is 1, it is 1. If it is 2, it is 2. There is nothing like a fraction or something. Please note the keywords here too. Every digital computer cannot attract its own data. It rather accepts data from a user. So this means that someone has to feed data into a digital computer before it can work. Without someone feeding data, a discrete computer would not be able to work on any data at all. It cannot even get data, let alone it working. And note that the data is always processed in the form of electrical signals. I already mentioned that every digital computer is electronic in nature. It uses a lot of electricity and electrical pulses throughout its operations. You know what electrical pulses are, right? In your integrated science, JSS and SS2, you are learning it, right? So a pulse can be on or off. When a pulse is on, we represent it by 1. If it is off, we represent it by 0. So it will be generating a lot of pulses, zeros and ones. Okay, then it will work on these zeros and ones using the same form of zeros and ones, then produce a result for us. As I have explained, there are only 2 states of electronic pulses, and these are on and off. A digital computer, in generating the pulses, represents an on state with 1 and an off state with a 0. So when there's a pulse which is on, then 1 will be used to represent that on state. If it is off, then 0 will be used to represent it. I've already explained discrete form to you. I explained that data can only be sent into a digital computer electronically. You can only feed data into it electronically. There's no other way. It doesn't have any physical or natural means of getting data. No, someone has to feed it with its data in electrical form. For instance, you have your keyboard, you have to type. As you type, you are typing it electronically. As you type, the signals will be generated electronically, and then it will go and then into the system for processing. That is, in accepting data, digital computer generates the appropriate electrical signals to represent the data being entered. So if I enter 12, the appropriate electrical signals or pulses in the form of zeros and ones will be generated and then go into the computer. Then once it enters the computer, it will be processed as such. It then represents the signals. I think I've already explained this one. I have explained this. Once data is properly converted and represented in zeros and ones, then the data can be worked on or processed. Now, the zeros and ones forms the language of the computer. So whenever you hear zeros and ones for computer, zeros and ones forms its language, and that language is called machine language. Machine language. Therefore, if you are asked what the language of the computer is, you should say machine language. And if you see zeros and ones, then it tells you the language is in binary digits or numbers. So binary numbers can either be on or off. Okay, there's no middle point or something. So if you are having you are to draw, how do we even call it? If you are to draw it graphically, is that you have a block standing up as 1. Then if it's down to the 0 level, then it means you have a 0. Okay, that is to the X line, right? Then it is 0. But if it rises up again, then you have a 1. If it goes down again, then it's a 0. But for analog ones, it will be in a form of wave, which is it may rise small, fall small, rise small, fall small. You see it. I hope you understand me. Let us look at the characteristics of a digital computer. Every digital computer is automatic. When we say a digital computer is automatic, it means that it can work on its own. Okay, it can work on its own, provided it is given the right instructions. Right. So first of all, instructions are given to the digital computer. Once the instructions are given, it doesn't need you to do any other work again. It will work on its own to produce the results. For instance, if let's say you want to compute the total of about 5 numbers, all you will do is to type the numbers into the calculator on the computer. Then after entering the numbers, that will be all. Right away, the computer on its own will work, and then the results will be displayed to you. So we say it has the ability to work automatically. Another example is if you want to watch a movie, once you slot in the CD and then you choose a program to play it, the moment you ask it to start playing, it will continuously play on its own. You don't do anything to regulate the playing. You don't work any way to affect the playing. It will be playing along till it finishes. If you want it to pause, it will. You just give a command to the program that pause, and it will pause on its own. You don't pause it. The system will pause on its own, and then if you ask it to continue, it will continue. Okay, so it has the ability to work on its own. Every digital computer is electronic. For analog computers, they are not electronic. Analog computers are not electronic. They are mostly mechanical. Check a car, for instance. The speedometer in a car. I'm not talking about the new ones that are coming new, but the normal cars. You notice that their speedometers are mechanical in nature. They are not electronic. But for every digital computer is always electronic in nature, which means it uses electricity to work, and then it generates electrical signals or pulses throughout its operations. Okay, that is what makes it electronic in nature. Then we say another characteristics of digital computer is it is digital. Digital means it processes data in the form of zeros and ones only. Okay, first of all, it will generate its data in the form of zeros and ones. Then it will use instructions in the form of zeros and ones to operate on the data, which is also in the form of zeros and ones, and produce results in the form of zeros and ones. But of course, you don't see the zeros and ones on your screen. We'll come to those things later on. Another characteristic of a digital computer is it has speed to process a lot of data in a matter of seconds. It can work very fast. Every digital computer can work very fast, unlike analog computers. So if you remember, I told you, for instance, if we were using a human being, let's say as a you let me take that one out and let me concentrate on this. So it can work fast. Okay, it can work fast. If in a matter of minutes or seconds, if you need some work to be done right away, you are done. It's easy for you to finish your work in no time. If you want to calculate for a figure in a matter of few seconds, you get your results. Okay, if you want to do some sort of simulation, the computer, if you give it the right proportions of variables right away, your computer does that simulations for you. So it has speed to process a lot of data in a matter of seconds. It doesn't take too much for it to process data. It takes very little time to do so. Information from digital computers are normally or mostly accurate when given the right instructions. Do you remember I mentioned GIGO, garbage in, garbage out? Therefore, the computer, as I said, does not make mistakes. Rather, if you feed it the right instructions and data, the right results will be produced for you. But if you don't do so, the wrong results will be produced. So everything that comes out of the digital computer is considered as accurate. Let us look at some of the differences between digital computer and analog computer. The first difference between analog computer and digital computer is that for analog computer, it can perform only one task at all times. That is, if it is expected to do one thing, if it is designed to be performing a particular task, it can perform only that task throughout its existence. So let's say, for instance, for a speedometer, if it is to measure the speed a vehicle travels, then it will be all the time measuring that one alone. It can't do any other work besides that. If a thermometer is supposed to measure your temperature, it can only measure your temperature and nothing else. I hope you understand me. But for digital computers, they can perform so many tasks at the same time, or even at different times. So at one time, for instance, now I'm displaying the PowerPoint presentation on the screen, and then I'm also recording the presentation. I'm also recording the sound and the visuals or the motion graphics as well. So you see it. You can do so many things at the same time using digital computers. For instance, you can be typing a letter, and at the same time you can be playing music, whilst probably you are converting, let's say, a video file from AVI to maybe MP4. You notice it. So you can perform several tasks at the same time on a digital computer, and you can do different things at different times if you so wish on digital computers, but you can't do same on analog computers. Once they have been designed to do this, that is all. You can't do anything else. Let us come to the second difference. For analog computers, data is from a physical condition, object, or system. It attracts its data from a physical object or from a physical condition or from a physical system. But for digital computers, their data is always given in electronic form. Okay, it is always given in electronic form, and someone enters that data. So it is it doesn't have the ability to attract, right? But rather it accepts data in electronic form. So that is the second difference. Then for the third difference, for analog computers, you always measure something. Analog computers, they are always used for measuring something. Besides measurements, they don't do anything again. But for digital computers, they are not. They may be used to measure something. They may be used to count certain numbers. But beyond that, you can do several things. You can measure, and then you can do other functions as well. They are not necessarily used for measurements alone. The fourth difference is that data for analog computers, data changes smoothly as I use the waveform graph to explain to you. For digital computers, it is not like that. Its data does not change in a smooth way. If we were to draw a graph to show, rather data changes in discrete steps. That is, from one high step to a low step, high, low, in a great jump. You notice it. Another difference is there is a limit to the accuracy obtainable for analog computers. What are we trying to say here? Whatever measurement an analog computer comes out with, or whatever results an analog computer comes out with, it may not be so accurate. It may be somewhat accurate. For instance, if you are using your eyes to gauge where a measurement reaches, your eyes may deceive you. It may be either above or below, okay, what you expect. So that is why we say accuracy obtainable is limited. But in the case of digital computers, accuracy obtainable is theoretically unlimited, which means you can expect that whatever results that comes out of digital computers all the time is accurate or is always correct. There is no room for doubting those results. So I'll leave you in a while to observe these differences. Then we shall continue. Alright, let's proceed. We come to hybrid computers. Hybrid computer is a type of computer that combines the characteristics or features of the analog computer and that of the digital computer. So it has some of the features of a digital computer, and some of the features are also analog computer in nature. And so it takes part of the features of analog computer, then it takes part of the features of digital computer, and they come together, fuse together to form a hybrid computer. So in essence, first of all, a hybrid computer takes data in through its analog features, that is through its physical features, right? So it has the ability to attract its own data. Then after it has attracted the data physically, then it works on the data to produce a result through its digital features. So here it will first of all take data through its physical features. Then the data taken is converted and passed on to the digital features to compute the expected results. Though it has the features of both analog and digital, its operations, that is, the hybrid computers' operations, are mostly controlled by the digital features. Examples of hybrid computers are ATM machines. You notice that ATM machines, you first of all go and stand by the machine and then insert your card, type some figures on the control board, right? That part is digital part. After typing whatever information you need to type, then the money is counted and then sent out to you. Now, money is a physical object. It is not electronic. You can physically touch money. You pick money. Money is not electronic in any way. And we cannot use a computer to form money. We don't do that. It is physical. First of all, the money is placed somewhere. Then the physical part of the hybrid computer will be picking or pulling out the money bit by bit, and then the digital part will be observing. So when it reaches the end, then the digital part will stop money from being picked out or brought out to you again. Then we have electronic hydrometers. Examples also are electronic scale. Then we have money counting machines. Money counting machines, you normally see them in our banks and forex bureaus and so on and so forth. Hybrid computers process data in both analog and discrete forms. So it has the ability to measure in a continuous way, and also has the ability to work on discrete data. These are images of the examples we stated. You have the electronic sphygmomanometer. You see it is different from the first one we saw. Then you see an electronic weight scale. You see it's different from the first one we saw. Then we have ATM machine. You see it. Then we have fuel injector or fuel pump or fuel pumping machine, whatever one you will call it. The one we use to pump gas and petrol and diesel into our vehicles. Then we have money counting machines. Then we have electronic hydrometer. Then we have electronic thermometer. You notice, look at the tip of this thermometer. So this one is a part which attracts the data. Okay, so you fix it in your armpit or in your mouth, then it will be attracting the data. Then this part will be showing you the results, right, in electronic or digital form. Alright, so we shall pause here, take a break, and then continue with the discussions later on.